Hello everyone, this is Mrs. Mooney, and this video is covering geometric sequences. Alright, we're first going to start by defining a sequence as a list of numbers, any list of numbers at all. An example of a list of numbers could be 11, 22, 44, 88, etc. Alright, but now to make a geometric sequence, I'm going to first put these numbers in a table. And when I look at these, I'm going to look at n being the position number, term number 1, term number 2, term number 3, and so on. And then f of n is going to be the term. So the first term was 11, the second term was 22, the third term was 44, the fourth term was 88. And then I want to look at the relationship between each of these terms. So if I look at this term 11 and then the next term is 22, I'm going to ask myself, how can I get from 11 to 22? And there's more than one way, but the most obvious thing is adding 11, right? But then see, if I added 11 to 22, I wouldn't get 44, so that's not going to be our pattern that we're looking at. Another thing we could look at was multiplying it by 2. So 11 times 2 is 22. And then if I multiplied by 2, 22 times 2 is 44. And then if I multiply by 2 again, so I'm going to write this on here. Look, from 11 to 22, we multiply by 2. From 22 to 24, we're multiplying by 2 again. And from 44 to 88, we're multiplying by 2 again. So that's our relationship in this. So we're going to let each of these be our term number. N stands for your term number. And each of these is your term, or f of n. And we said each term was multiplied by 2. And that 2, that everything is multiplied, we're going to call that the common ratio. And we'll use an R for our common ratio. So if we wanted to take this sequence of numbers and figure out an equation to get each term, our first term, I'm going to say a sub 1 for our first term. A sub 1 was 11, and then times 2, but it's not. So if I raise 2 to the 0 power, 11 times 2 to the 0 power gives us our first term. Our second term, that's going to be 11 times 2, and that's to the 1 power. Our third term is 11 times 2, and then times 2 again, right? Because we did times 2 and then times 2 more, so that's times 2 to the second power, 11 times 4. Our fourth term, we went times 2, and then we went times 2 again, and then we went times 2 again, so we went 11 times 2 to the third power, right? 2 to the third power is 8, times 11 is 88. So we could figure out our pattern by taking each term, f of n, each term is going to be 11 times our common ratio 2, and then look at the power. When we're doing term number 1, our power is 0. For term number 2, our power is 1. For term number 3, our power is 2, and so on. So we're raising it to the n minus 1 power. That's our equation for this geometric sequence. So that takes us to different kinds of rules that we can write for our geometric sequences. When we write an explicit rule, the explicit rule is always going to be f of n is equal to, and then f of 1, whatever your first term is, which in the example that we just did, our first term was 11, and then r is your common ratio, so for ours it was 2, and then we're always raising it to the n minus 1 power. So write this in your notes, f of n is equal to f of 1 times r to the n minus 1 power. Important, important, important. So if you look at number 1 on the worksheet, that's actually what we've been working with. We had f of n, number 1 on the worksheet says f of n equals 11, and then in parentheses 2 to the n minus 1 power. So that is the one we were just working with, where our first term was 11, and then our common ratio is 2 to the n minus 1 power. And then it says to write it as a recursive rule. So I'll show you all recursive in just a minute. So while your explicit rule is relating, is an equation relating each number that you get to its position, n, a recursive rule is an equation relating each term to the previous term. Let's write that down. So if you look at the one that we've been working on, number 1, it was 11, and then 11 times 2 to the second power was 22, and then 11 times 2 to the 2 to the first power was 22, 2 to the second power was 44, 11 times 2 to the third power was 88. If we said, well, how does each term relate to the previous term? When we looked at it before, we said it's every term was the previous term times 2. So if we're saying each term is the previous term times 2, then each term, f of n, that's our term, equals the previous term is written f of n minus 1, because if I want the first term, if I want the second term, then n would be 2, and n minus 1 would be 1, so I would look at the first term, the one before it. Each term is the previous term times 2. So that's how you write a recursive rule, only there's a couple of extra things you have to put in, and if you look at number 2 and number 3 on the geometric sequences worksheet, you'll see how that's supposed to be written. It's always going to be written f of 1, f of 1 equals a, whatever your first term is. It's going to give you some number, then there'll be a semicolon, and then your rule like we just wrote, f of n equals f of n minus 1 times r, whatever your common ratio is, and then there'll be a comma, and then it'll say, hang on, let me scoot this, and then it'll always say n is greater than or equal to 2, because we're always going to start with the second term. You're always given the first term, a, and then your n's will start with your second term and on up. So we always write it like this. F of 1 equals a, semicolon, f of n equals f of n minus 1 times r, comma, n is greater than or equal to 2. So the only things that you need to know to fill in that equation are a, your first term, and r, your common ratio. So on number 1 on the worksheet, So on the worksheet, let's move this up a little bit. We had f of n equals 11 and then 2 to the n minus 1. Then we know that 11 is our first term, and we know our common ratio is the 2. So we're just rewriting it from one form to the other. We're going to say f of 1 equals 11, semicolon, and then we say f of n equals f of n minus 1 times, and then our common ratio is 2. Then we put a comma, and then we write n is greater than or equal to 2. So this is how you would write the answer to number 1 on your worksheet. All right, so let's do number 3 then on the 13-1 worksheet together. I've written out what it says on there. If you don't have the worksheet, you can just write this down in your notes. It says f of 1 equals 27, f of n equals f of n minus 1 times 1/3, for n is greater than or equal to 2. So 27 and 1/3 are the only new things that are in here. And if we remember correctly, 27 is our first term, and 1/3 is our common ratio, or your r. And if you remember correctly, our explicit rule is always written f of n equals the first term times the common ratio to the n minus 1 power. So, for number 3, we would write f of n equals, and our first term, f of 1 is 27, and our common ratio r is 1/3. Make sure you put it in parentheses to the n minus 1 power. If you don't put it in parentheses, if you just wrote 1/3 to the n minus 1, then you are technically only raising 1 to the n minus 1 and not the 3, and that's not what we're trying to say. So you must put it in parentheses. Super important parentheses. All right, so there's number 3. All right, let's do number 5 together on the worksheet. This one, the instructions just say write an explicit rule for each geometric sequence based on the given terms from the sequence and assume that the common ratio r is positive. So, because you could have negatives, but we're going to assume it's positive for all of these. So number 5, it just gives us A1 and A2, and all we have to do is write the explicit rule. Recursive is kind of a pain to write, but you do need to understand how it works. So it's very important that you make sure you understand how that works, looking at the last example. All right, A1 is 90, A2 is 360. So we just need to figure out, in order to write an explicit rule, we need our first term, and that would be this one, right? The 90 is our first term. And we need our R value, which we don't know yet, but we know what would we multiply 90 by to get 360? 90 times 4 is 360. Just divide 360 by 90, you're going to get 4. So now we know our R value. Okay, so when we write the explicit rule, we write f of n equals, and then we write the first term, 90, and then we write the R, just put it in parentheses every single time. 90 times 4, and then it's always to the n minus 1 power. It's that easy. Now let's do number 7. This one's not as easy because it gives us the first term, A1, so we've got one thing that we need, but it doesn't give us the second term, it gives us the fifth term. A5 means the fifth term is 162. So we know our sequence is 2, comma, something, 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 1, 2, 3, 4, and then the fifth term is 162. So how are we going to figure out what the R is? All right, we're going to set up our explicit equation. Our explicit equation is always f of n equals, and then the first term, which in this case is 2, times, and then we don't know r yet, to the n minus 1 power. So we know the fifth term, so we're going to use that. We're going to say f of 5, the fifth term, is 2 times r to the 5 minus 1, right? Because if n is 5, then n minus 1 is 5 minus 1. So our fifth term, we know, is 162 equals 2 times r to the 4th power. And now we're just solving equations like we did before in the last chapter. So first thing we have to do is divide by 2. We can't take the 4th root yet. We have to divide by 2 first. So 81 equals r to the 4th power. And now we can take the 4th root of both sides. The 4th root of 81 is 3. And the 4th root of r to the 4th is just r. So now we know our common ratio, 3. r equals 3. And now that we know the common ratio and the first term, then we can go back and write our f of n equals the first term 2. Common ratio is 3, and then it's always n minus 1 power. There's number 7. All right, here's number 9. This time, they didn't give us the first term, but they gave us A4 is 135, and A sub 5, the fifth term, is 405. So instead of figuring out the common ratio, we have to figure out what the first term is. The common ratio we can figure out because we've got from 135 to 405. If I just divide 405 by 135, I know I multiplied by 3. And that's my common ratio. So I know the R. So I'm going to do what I did last time. F of n equals the first term, f of 1, which we don't know this time, times, and then our common ratio is 3 to the n minus 1 power. and I'm going to plug in these. So 405 equals, and then I don't know the first term, times 3, and that's to the, n was 5, so 5 minus 1 is 4th power. So 3 to the 4th power is 81. And if I divide both sides by 81, then I know that my first term has to be 5. So now I can write the equation. F of n equals 5 times 3 to the n minus 1 power. Alright, now 11 gets even uglier, because now they've given you a 2 equals 80, so the second term is 80, and a 5 is 10, the fifth term is 10, so we don't know the first term, and we've got 3 skips, so we don't know the common ratio, because we can't just go from one to the next. So we get to do a system of equations. We're going to take the first one that we have, f of 2, term number 2, equals the first term, f of 1, times the common ratio to the n minus 1 power, where n is 2. Sorry, I should have just written 2 to begin with. So the first term times r to the 2 minus 1 power, and I'm going to plug it in. My second term is 80. We don't know the first term. We don't know the common ratio, but 2 minus 1 is 1. So I'm going to say, all right, well that means that my first term, I'm just going to divide both sides by r. My first term is 80 over r, because r to the 1 is just r. All right, then I'm going to take the other one that I've got and plug it in. So f of 5, the fifth term, is the first term times r to the 5 minus 1, which means f of 5, the fifth term, is 10, equals the first term times r to the 4th. All right, and then what I'm going to do is I'm going to plug in, let me get a different color. Over here I said f of 1 was 80 over r, so I'm going to plug that f of 1 in with 80 over r. So I've got 10 equals 80 over r times r to the 4th. And if you want, you can put that over 1 so that you can put these two together. We now have 10 equals 80 r to the 4th divided by r. That's to the 1 power, so remember we subtract our exponents, 80 r to the 3rd. So continuing on, if 10 equals 80 r to the 3rd, divide both sides by 80. 10 divided by 80, that reduces to 1/8 equals r to the 3rd. And then when we take the cubed root of both sides, I know y'all look at cubed root of 1/8 and go, well, I don't know what that is, but you know the cube root of 8 and you know the cube root of 1, so the cube root of 1/8 is 1/2 equals r. Now we have our common ratio. All right, then we're going to take that and plug it back in right there, because we knew f of 1 is supposed to be 80 divided by r, and r is 1/2. So if I take 80 and divide it by 1/2, you can punch in your calculator, just make sure you use parentheses, or remember, dividing by a fraction, we multiply by the reciprocal, so our first term is 160. 80 times 2 is 160. So now we know both of the things we need. We know our r, and we know our first term. We can write the equation. And the equation will be f of n equals the first term, 160, times r, which is 1/2, to the n minus 1 power. All right, finally, we're going to do the word problem at the bottom. I copied it on here so you could see it if you don't have the worksheet. It says a bank account earns a constant rate of interest each month. The account was opened on March 1st with $18,000 in it. On April 1st, the balance in the account is $18,045. Use this information for problems 13 through 15. And then 13 says write an explicit rule and a recursive rule to find a sub n, the balance after n months. So to write either of those rules, what we need is the first term, and we need the common ratio. So through this word problem, we know that the first term is $18,000. So our first term is 18,000. And our common ratio, we have to figure out, but we know that the second term, the second month, because March 1st to April 1st is 1 month, was 18,045. So what would I multiply 18,000 by to get 18,045? Just divide 18,045 by 1,800, and we know we're multiplying it by 1.0025. So that's our common ratio. 18,000 times 1.0025 will give us 18,045. So then to write the explicit rule, it says to write a sub n instead of f of n. So instead of using an f, we'll use an a, but it's the same setup. A sub n equals, and then the first term is 18,000. And then the common ratio, put it in parentheses, 1.0025. And then it's always raised to the n minus 1 power. So there's your explicit rule. And then your recursive rule, hopefully you wrote this down, so look back in your notes. We're always going to write, it says f of 1, and we'll go with a of 1 because we're using an a this time, equals 18,000. You write your first term down, and then you put a semicolon, and then the equation a of n equals a of n minus 1 times, and then the common ratio, which is 1.0025, then comma, and then we always say n is greater than or equal to 2. So there's your recursive rule. Recursives are kind of a pain to write. All right, number 14 says find the balance after 5 months. So I'm going to because I'm letting you guys do the evens as your homework, I'll let y'all do that one. But really all you have to do is plug in a 5 for your n and put it in the calculator. And then 15 says find the balance after 5 years. So remember our n is calculated in months. So on number 15, if we want 5 years, we have to figure out how many months that is. And 5 times 12 would be 60 months. So our A of 60, our 60th month, is going to be 18,000 times 1.0025 raised to the 60 minus 1 would be 59th power. And then, of course, you need a calculator for that. But when you put it in the calculator, you will get $20,856.96. All right, so that is the end of this video. Remember, you can go back, rewatch parts, pause it, and then, of course, join your teacher, ask your teacher if you've got any questions over anything in here. Thank you. Bye.